On the front lines of early 20th century warfare, especially during World War I and the interwar conflicts that followed, cooking was not a comfort activity. It was a survival operation carried out under fire, in mud, wind, rain and freezing nights. Soldiers could not rely on open campfires or bulky stoves. Smoke gave away positions. Fuel was scarce. Equipment had to be fast, low profile and nearly indestructible. The reality was harsh. Soldiers had to prepare their meals in the worst imaginable conditions, right there in the trenches with little protection from the elements. Every meal was a challenge, and the risks were constant. Out of that pressure came a forgotten solution that many veterans remembered long after the wars ended: the Frontline fire basin. It was simple in appearance, brutally effective in practice, and capable of cooking almost anything with minimal fuel and minimal visibility. Why did conventional cooking fail at the front? Standard fires failed soldiers for several reasons. Open flames attracted attention and artillery. Raised stoves required fuel transport and set-up time. Trenches and shell holes flooded easily, drowning fires or scattering heat uselessly into the air. Soldiers needed a way to trap heat, concentrate it and hide it at the same time. You know, the answer wasn't a new fuel or some exotic material, but rather a change in how fire itself was contained and controlled. How did the fire basin design quietly spread among frontline units? Well, the fire basin was not an officially issued piece of equipment in many armies. Instead, it spread through improvisation. Soldiers used shallow metal basins, broken helmets, ammo tins, mess trays, or even scavenged farm pans. The shape mattered more than the material. The basin sat low to the ground, often recessed into soil, rubble, or trench walls. Fire burned inside the container rather than on the surface, immediately reducing wind interference and light spill. Because the heat was contained and reflected inward, even small amounts of fuel produced usable cooking temperatures. Why did the basin trap heat better than open fires? The key advantage was thermal concentration. The curved sides reflected radiant heat upward toward cookware. Ash and embers accumulated rather than dispersing, creating a stable heat bed. When partially buried, the surrounding earth acted as insulation, reducing heat loss and protecting the flame from rain or snow. This meant soldiers could boil water, cook stews, fry meat or heat rations using twigs, broken crates, charcoal fragments, or even dried grass mixed with grease. The basin turned marginal fuel into reliable heat. How did soldiers use the basin to cook nearly any food? Well, cooking with the basin followed a consistent method. First, a shallow pit was scraped, or the basin was wedged into an existing depression. Fuel was layered carefully, with denser material below and fast-igniting material on top. Once lit, cookware rested directly on the basin rim or was suspended slightly above it using wire, bayonets, or scrap metal. Because heat rose evenly and stayed focused, thick foods cooked without scorching while liquids boiled faster than expected. Soldiers cooked soups, bread dough, potatoes, beans, canned meat, and even improvised flatbreads using the same setup. Why did this method work in rain, wind, and snow? Well, weather usually defeated normal fires by robbing oxygen or dispersing heat, but the basin resisted both. Wind flowed over the top rather than through the flame. Rain hit hot metal and evaporated before drowning embers, and snow melted into the basin's outer edge instead of collapsing the fire. Some units went further, placing a loose cover of metal or stone over part of the basin to create a semi-enclosed oven effect. This allowed baking or slow cooking while reducing visible light at night. How, you might wonder, can modern survivalists apply this forgotten technique? Well, this method translates directly to modern off-grid or emergency scenarios. A shallow metal pan, an old frying pan, a steel bowl, or even a thick aluminum container can function as a fire basin. The steps are honestly quite straightforward. Set the basin on bare soil or partially bury it. Load fuel in layers. Ignite carefully. Place cookware directly on the rim, or if you prefer, slightly elevated. Compared to open fires, this uses less fuel, produces less smoke, and works in adverse conditions. It's ideal for discrete cooking winter use, or environments where fuel is limited. Why did the fire basin outperform later portable stoves? Well, portable stoves improved convenience but sacrificed flexibility. They depended on specific fuels and moving parts, but the basin needed none of that. It accepted anything combustible, you see. It couldn't clog, crack easily, or fail mechanically. Soldiers trusted it because it worked regardless of supply lines or conditions. This reliability explains why variations of the basin appeared again during World War II, in resistance camps and among displaced civilians long after the original conflicts ended. What this forgotten tool reveals about frontline ingenuity. The fire basin was not a product of comfort. It was a response to pressure, danger, and scarcity. It shows how soldiers understood heat, airflow, and materials intuitively. They solved problems with what they had, not what manuals recommended. For historians, it highlights how, unofficial knowledge often mattered more than doctrine. For survivalists, it proves that low-tech solutions can actually outperform complex systems when conditions deteriorate. Why does this method deserve renewed attention? In a world where power failures, fuel shortages and extreme weather are, frankly, no longer just theoretical, the fire basin remains relevant. It teaches control over fire rather than dependence on equipment. It teaches efficiency rather than excess. For serious students of history and preparedness, this is not merely a curiosity. It is, in fact, a working technique with a century of proof behind it. If this exploration of lost frontline wisdom added value to your understanding of survival history, please support Backyard Wisdom by subscribing, sharing this episode, and, helping keep practical, experience-driven knowledge alive for future generations.